Hi everyone, welcome to my channel Math Made Easy with Terry in 10 minutes. So we're going to the fifth rule now of integration, and we'll talk about the exponential rule. So here we're going to talk about there are three forms altogether. We have the e raised power x, a raised power x, and ln x. Okay, but in this video, I'm going to talk about the exponential rule of e raised power x. So I'm going to call it 5a. All right. So before I proceed, I always like to say, don't forget to like, share, and subscribe. If you have any question, please do let me know in the comment section, or you can email me directly. Also, if you've not clicked the notification bell, I don't know what you're waiting for, so that when I post new video, you'll be the first person to know. So just what I just said, we have generally there are three forms, okay? There are three forms here. We have the exponential that are e raised to power x, okay? We have the exponential that is a raised to power x. So for instance, you could have something like exponential with 3x, something like this. You're told to integrate something like this. Or you could be told to integrate maybe 4 raised to power 2x, something like this. Or you could have a ln x. So for example, you're told to integrate ln 5x, okay? So all these are different forms of exponentials, but in this video, I'm gonna focus on the exponential raised to power x, okay? Please make sure you review previous videos as well as the differential videos, and always remember, always bring out the constant. When there's a constant, when you're integrating, always bring out the constant. All right, so let's get cracking then. Let's talk about how to integrate. So let's talk about how to integrate. That's integrating the e raised to power x. Okay, so let's talk about e raised to power x. So it could come in different form. You could see it as e raised to power x. Some textbook can write it as e raised to power ax. Okay, that means there's a constant in front of the x. Or it could be exponential of a particular function. All right, so it could be any of this, and you were told to integrate. So what you do when you're integrating exponentials, especially e raised to power x, e raised to power ax, or e raised to power f of x, there are three steps to take note of. Okay, so we talk about the three steps so that when you're doing this, you need to do. So the first thing is that you have to do is that you have to first differentiate the power. All right, so like for instance, in this case, the power is x. The power in this case is a raised to power x, and the power in this case is f of x. So you have to first differentiate, okay? So you have to first differentiate the power, okay? So you have to first differentiate the power. Like in this case now, the power we have x is equal to 1, or you can have the power here. When you differentiate ax, it will give you a, or when you differentiate f of x, when you differentiate, it's going to give you f prime x. So when you have to first differentiate the power. Now, number two, after differentiating that, now you have to then divide the original question with the answer from step 1. So you have to then divide the original question with the answer from step 1. And number three, maybe let me just give a classical example. So if, for instance, we have e raised to power x, okay? If, for instance, we have e raised to power x, we know we've differentiated this and we got 1, so it's going to be e raised to power x divided by 1. If we have e raised to power ax, we differentiated ax to give you a, so it's going to be e raised to power ax divided by a. Does that make sense? Or if it's a function, it's going to be e raised to power f of x divided by f prime x. So basically that's what we are talking about. Now, when you're done with that, number three, you then add c. Okay? So you then add c to the new integral value. So remember, you only do this in indefinite, only in indefinite integration. Okay, so very soon I'm going to explain the concept of definite and indefinite. So at the end of the day, you're going to have, for instance, you're going to have EX plus C. In this case, it's going to be EAX divided by A plus C. Or in this case, it's going to be EF of X divided by F prime X plus C. All right, so that's how you do it. So that's the 3 steps. Okay, so the first thing you do, you differentiate the power. When you differentiate the power, you divide the original question with the answer from step 1, and then you add C if it's indefinite. Let me pick some example here. So let's assume we have this example. All right. We have this example here. Let's pick number 1. We have 5 exponential x. Okay, and you are told to integrate this in respect to what? X. So like I said, for everything, you always bring out the constant before you integrate. So that means this is going to give us 5, the integral of what? Exponential x, what? Dx. So step 1, all right, what do? So we said you have to differentiate the power. So when you differentiate x, it's going to give us what? 1. Does that make sense? So we have to differentiate the power first. So when you differentiate x, it's going to give you 1. So then step 2, we then have to divide the original question. So it's going to become 5 into brackets, the original question, divided by 1. Then step 3, you then had what? C. It's going to be 5 exponential x divided by 1 plus c. And this is going to give us 5 exponential x plus c. Okay? So that's the thing you need to keep in mind. So you have to first differentiate the power, then you divide the original question by the power. And remember, like we said earlier, if there is a constant, you always bring out the constant. Is that okay? Now let's pick another example. Let's say number 2 now, all right? Let's assume we have 1 over 4 exponential x minus 1 over x, all in respect to what? Dx. So we're told to integrate this all in respect to dx. So similarly, the difference rule, so what you do, this is the same thing as now saying, we're integrating 1 over 4 exponential x minus we're integrating 1 over x, okay, all in respect to x. So the same thing I told you, you have to bring out a constant. It's going to be 1 over 4 integral exponential x minus integral of what? 1 over what? X. So same thing. The power here is x. Okay, so x, when you differentiate x, it will give you 1. So you divide this by the original question. So it's going to be 1 over 4 divided by exponential x divided by 1 minus reciprocal function. We talked about this already. So when you integrate 1 over x, it's going to give us what? Ln x. Then you also add what? C. So this is going to give us 1 over 4 exponential x minus ln x plus c. All right. All right, let's pick another example. Number 3. So let's say we have this example here. We're told to integrate 3 exponential 4x in respect to what? Dx. Okay. So as usual, you bring out the constant. So we have 3 integral of exponential 4x in respect to what? Dx. So the first thing first here, step 1, what do you have to do? You have to differentiate the power. So the power is 4x. When differentiate 4x, is going to give you what? 4. Now, step 2 is that we have to then differentiate, divide the original question by 4. So it's going to be exponential 4x divided by what? 4. Then step 3, we then have to add what? Plus c. So it's going to give us 3 into brackets, exponential 4x divided by 4, okay, plus c. And when you solve this, you open the bracket, it's going to give us 3 over 4 exponential 4x plus c. And that will be the answer for that. Okay, so basically you can see it's the same thing. You just differentiate the power, you now divide it by the original question and you add c to it. Let me pick one more in this for this video. I will call it a day. Let's assume we have this time, let's assume we have a function. Let's assume we have a quadratic function here. So you have x squared plus 2 in respect to what? Dx. So we're told to integrate this, x squared plus 2 in respect to dx. So step 1. So the power here is x squared plus 2. Now, when you differentiate x squared plus 2, it's going to give you what? 2x. So step 2, we then have to divide the original question, which is exponential x squared plus 2 divided by what? 2x. Then step 3, we now have exponential x squared plus 2 divided by 2x plus c. And that will be the answer for that. Okay? And that is how you do exponential functions. So what I'm going to do, I'm going to give you some examples to try. Okay, let's try some examples, some exercises. So you just try this with your friends and see if you get the same thing. So let's assume you are told to integrate 5 over 3 exponential 2x in respect to dx. Let's assume we have this one, exponential, integrate exponential of x in respect to dx. Number 3, we're integrating 5 exponential. Let's assume we have a function 6x squared in respect to x. And number 4, we're integrating a linear function 3x plus 4 in respect to what? X. So try this, put it in the comment section or discuss with a friend and see if you get the same thing. Now, and that is that for exponential function, all right? So the next video, we're going to go straight to now when we have a raised to power x. So it's very important that you subscribe and you also click the notification bell. So when I post the next video, you'll be the first person to know. All right, so I'm going to see you soon. I'll see you in the next video where we talk about a raised to power x. How do you differentiate questions like that? See you soon.